Hey, this is Gary again. We're back at Extron's AV Technology Open House. This is our last stop on the tour here in Vegas. And I'm with Dave Pinchek, VP of Product Development. Dave, how are you?
I'm doing great, Gary.
So look, Dave and I have known each other a long time, so that's okay. But listen, we're going to talk about something you may not even realize you need to care about. And so can you imagine if you're a college campus and you've got audio amplifiers in every single classroom, 150, 200 classrooms, that's using a lot of power, that's costing a lot of money. You were the first manufacturer to have Energy Star amplifiers, right? Energy Star compliant amplifiers.
That's right. We're the first company in the rAVe industry to do Energy Star.
Yeah, and that meant that you were following guidelines and kind of explain sort of what the industry standards are. And I want you to explain what you've done with this new amplifier because it's quite unique and it's going to save people a lot of money in that application.
Yeah, sure. Okay, so Energy Star, in order to be Energy Star compliant, the amplifier has to automatically go into standby. And typically what happens, we wait till we don't hear any audio, and after 30 minutes, we go into standby. In standby, we draw less than a watt. And so
is that 30 minutes a standard that Energy Star came up with?
Yeah, that's a industry standard, okay. Right. And so when we hear audio, we wake back up.
Right.
And our first generation of amplifiers, it took us about half a second to wake back up, to be back to full power, half a second.
Okay.
Half a second, you miss about a word or two. And that's where the entire industry is. They're half a second or longer to wake up.
So if you looked at all the other audio companies that have amplifiers, that's what they'd be?
Yeah, you miss a word or two before they're back to full power. Our second generation, we got that down to 100 milliseconds. 100 milliseconds is a syllable. Okay. So you miss a syllable, but we're back to full power in a pretty quick period of time.
After that 30 minutes.
After that 30 minutes of waiting to go into standby. Right. The latest generation of XPAUs, we can wake up in 5 milliseconds. 5 milliseconds is that fast. Yeah. If you walk up to a microphone and do that, you hear that.
You're going to hear the snap
because we're that fast.
Okay.
And because we can wake up so fast, we no longer wait 30 minutes to go into standby.
So if you're not waiting 30 minutes, does that mean, like, do you have to go back to Energy Star and have them change their guidelines, or how's that going to work?
Well, it would be nice to go back to Energy Star and have them one-up the game. They actually are in review of increasing the requirements. Yeah. Most of their increased requirements are trying to get less power during the standby time. But yeah, I don't know. We'll see what.
It'll be very interesting.
We don't have any control over Energy Star. They're a government entity.
But see, the thing is that during that 30 minutes times 150 classrooms, you're still using power at the same level.
Right. Your amplifier's at idle. Okay, and typically an amplifier at idle is drawing around 20 watts. So you got 20 watts being drawn for 30 minutes.
Times 150 classrooms. That's a lot. That's hundreds of dollars a month.
Right. So with this guy, we wake up in 5 milliseconds, and we go into standby in 8 seconds.
So you don't wait the 30 minutes, you go into...
30 minutes to when we have no audio, we do it in 8 seconds. So with this station, we can demonstrate, I can pull the audio out of pause, and you can see here, we're in standby, we're drawing less than a watt. The power supply is in a pulse mode, so it comes on, keeps the capacitors fully charged on the output, and then goes to sleep. And so you see that, that's why you see that oscillating. As soon as I hit this to play some audio,
there's also a microphone comparison section.
It wakes up as soon as I press the button. I'm going to pause that, and
within 8 seconds,
that's going to drop down to less than a watt.
And you can see on the amplifier.
Amplifier went to sleep already. We're at less than a watt.
Yeah.
And you can see as soon as I press that button, and you see here on the amplifier, I'm not controlling the amplifier. I'm only controlling pause on the player.
A lot of different instruments and styles of music on this.
Immediately turns on, immediately went up to the full wattage. So you're talking about saving thousands of dollars for a typical, on a campus like that.
Yeah, and it's not just cost savings, right? For us, it's longevity. Yeah. When you take heat out of a product, the product lasts longer, right? So when you go into this standby, we're pulling a lot of heat out of it. And the amplifiers are typically the device that heats up the entire rack, right? That's right. So we're increasing the longevity of all the equipment in the rack by pulling the heat out, by going into standby faster.
Well, there's also an environmental value too, right? I mean, everybody's trying to build products that are better for the environment. And in here, if you come to Extron's any of their showrooms, you'll be able to see this demonstrated. And here you're showing a rack and sort of all of the different ways you're addressing power.
Right. Most of Extron's products have the ability to be placed into a standby mode through what we call our SIS, or simple instruction set, via RS-232 or Ethernet. And by sending a command to a product, you can put it into a low power state and save typically 50%. So we can put a matrix switcher or a scaler into standby and cut the power in half.
Okay, and then, but you still have this InstaWake feature on the newer amplifiers.
Yeah, this is on the newest amplifiers, right?
Right. So, but in the current amplifiers, you have the ability to do that, and you're able to demonstrate that here.
Yeah, I can show here. Let me come around the side so I'm not in the way. Okay, so here's an amplifier running at full power. Actually, 2 amplifiers. We're pulling 155 watts. When I take the audio signal away and it goes into idle or quiescent, you can see it drops down to about 20 watts, and that's the amount of power it's sitting there pulling for those 30 minutes while it's waiting to go into standby with the current generation. When I put the unit into, I meant to press this a second time, put this guy into standby, it'll drop down. We have 2 amplifiers here, so it'll drop down to 1.5 watts, less than a watt each. This takes about 6 seconds to go into complete low power mode. There you go.
Okay.
So you went from 155 watts running full power, no audio signal, idle is at 20 watts, but in standby.
But the point here is that you've already been doing this in one form or another since the beginning.
Since we started doing amplifiers about 10 years ago.
Yeah, and so this is a good education. But this, one other thing to mention.
This is the next quantum leap.
And this is patented, right?
The circuitry for doing InstaWake is patented, yeah.
Yeah, and so therefore it's
patent pending.
It's the only way you can get it right now is the way the Extron's doing it. It'll be interesting but you're still ENERGY STAR compliant?
Yeah, the new model's ENERGY STAR compliant.
Okay, good.
It will be. We haven't put in. Actually, we did just finish tests. This guy doesn't have its sticker on it.
Yeah.
But yeah, it's ENERGY STAR compliant.
All right, and this is a brand new product that was just introduced. I remember writing this up just last week. So this is the XPA-U. 204, 2004 something?
We have the 2004 and 4004.
4004, okay.
Yeah, these are the ones that have
2-channel versus 4-channel, I guess?
Correct.
Okay, great. You can find out more information at Extron.
They're both 4-channel, I'm sorry, 200 watts versus 400 watts.
Okay, 200 watts versus 400 watts. There you go. You can find out more information at extron.com, and of course, or contact Dave. He loves this kind of stuff.
Yeah. Dave at extron.com.